All right, I'm assuming you already read the question and have some idea, and if you got stuck, let's see what we would do next. First, let's write out our equation. All right, so we got lead, 2 plus ions, and this Cl2 will turn into 2 Cl minus ions, correct? And so what is it asking us for? It's saying how much NaCl solids, that's a little bit weird, how much NaCl solid needs to be added in order to get the lead ions down to this concentration at equilibrium. So what we're saying is at equilibrium, we want our lead to be 1.2 times 10 to the negative fourth. So we don't know what this would be at that point in time. Here, we don't care about this because this is solid, so this does not go into our equilibrium expression. Let's write out our equilibrium expression. KSP. Sorry. KSP is equal to the concentration of lead ions times the concentration of chloride ions squared, right? Products over reactants. And we're saying that our KSP is 1.6 times 10 to the negative fifth is equal to, and we're saying at this equilibrium we have this much lead, 1.2 times 10 to the negative fourth. So how much chloride ion concentration must there be? Question mark. Well, let's just solve algebraically. We'll divide this side by 1.2 times 10 to the negative 4. That goes away. We'll divide this side by the same thing, 1.2 times 10 to the negative 4. Okay, and then we're going to get, I have it all written down right here, sorry. 0.13, repeating, is equal to the concentration of chloride ions squared. So let's take the square root of both sides. And we're going to get 0.365 molarity is equal to the concentration of chloride ions when lead is equal to 1.2 times 10 to the negative 4. So this is the number that goes here. Awesome. If you look, that is letter A, 3.65 times 10 to the negative 1. And if you select letter A, I'm sorry, you would be incorrect. That is not the correct answer. Because it's asking what mass of NaCl, right? So how do we get that? I'm going to write out all the stoichiometry, but most of this is 1-to-1, so it's a little redundant, I guess. So if I have, let me go ahead and make myself some room here. Okay, so if I have 0.365 molarity of chloride ions, then how many moles is that? Well, don't forget that molarity is moles per liter. And we're going to let our units dictate our math, moles per liter. So if I need moles, I'm going to multiply by liters. How many liters do I have? Luckily, it's 1. So 0.365 moles. That makes it easy. If it wasn't 1, though, it'd be really important to multiply by the number. So this is moles of chloride ion. What it's asking me is how much NaCl do I need to make that many moles? So I'm going to multiply by, for every 1 mole of NaCl, I get 1 mole of chloride ion. It's 1-to-1, but I just want to make sure we're covering all our bases. And it's asking what mass. So I've converted all the way now to moles of sodium chloride. So we can convert from moles to mass very easily by saying for every 1 mole of sodium chloride, I have 58.43 grams of sodium chloride. That's just the molar mass, right? We multiply that out. We are going to get 21.32 grams of NaCl. And that is answer choice D.